The James Webb Space Telescope, which people playfully call Webb or JWST, is a scientific giant that is uncovering fascinating facts about galaxies, stars, planets, and other things that happen in space. Webb has set new standards for scientific excitement by allowing people all over the world to share pictures and raw data that can help scientists learn new things. It is known as the venerable replacement for the Hubble Space Telescope. Astronomers all over the world are still amazed by the James Webb Space Telescope a year after it made its impressive appearance. Its most recent finding, on the other hand, draws a scary picture of the universe and may leave scientists with more questions than answers. Through this investigation, we look into how the James Webb Space Telescope takes the scariest picture ever seen. As the successor to the Hubble telescope, Webb has given us new information about how galaxies grow, how they merge, and the early universe. Just 1 month after its first pictures came out, the telescope showed off stunning pictures of the sky with details that had never been seen before. Since then, the number of findings has gone through the roof, giving scientists a huge amount of data. Webb has seen cosmic tarantulas, record-breaking space smoke, stars on the verge of supernova explosions, and many other things in space. He has used cutting-edge technology to record all of these observations. The satellite telescope lets us look farther into space, showing us things about the universe that we didn't know before. In honor of Webb's first year of use, NASA shared a picture of a small area in the Oort cloud complex where stars are being formed. The picture shows jets coming out of new stars, different colored cosmic dust clouds crashing into each other, and molecular hydrogen making up the red dust. NASA tells us that this stellar nursery is small and quiet compared to others because it has many young stars that are the same size or smaller than our Sunweb's near-infrared camera, which can take pictures in 2 different infrared ranges at the same time, was very important in getting this beautiful shot. Also, the camera has helped us learn a lot more about exoplanets, especially those that are about the same size as Earth. Webb found its first exoplanet, LHS 475b, which is 41 light-years away. This was a big deal because it showed how well the telescope could describe the atmospheres of exoplanets the size of Earth. Webb also found evidence of very old galaxies, which are called universe breakers because they challenge what we thought we knew about space. 6 very large galaxies that formed 500 to 700 million years after the Big Bang are much bigger than expected and may be billions of times heavier than our Sun. These huge objects, found by the telescope's infrared sensors, give us a look into the early universe and challenge what scientists thought they knew. Webb's amazing discoveries keep changing how we think about the universe and starting a new era in science. As the James Webb Space Telescope continues to reveal the mysteries of the universe, stay tuned as scientists try to make sense of these surprising findings. Scientists are now questioning the accepted theory about how galaxies formed in the early universe because of a new discovery we made. These galaxies are much bigger than scientists thought they would be. This goes against the idea that galaxies in this range are still babies and are still forming. To make sure these results are correct, we need to use spectrometry, a technique that breaks light into its individual colors so that we can accurately measure distances. Scientists are confused by the data because only a few of the newly found objects have confirmed their mass and distance. If this is true, it goes against what we thought we knew about how galaxies are made and points to a much faster and more efficient process than we thought. Dr. Katie Mack, a cosmologist, sheds light on the subject by saying that the James Webb Space Telescope shows that galaxies formed or grew older much earlier than what previous models predicted. Even though the pictures of galaxies more than 13 billion light-years away are a bit fuzzy, Mack tells us that the data from the camera shows that there hasn't been enough time since the Big Bang for such big galaxies to have formed. Scientists are worried that these results call into question many theories, such as dark matter and the Big Bang. However, it is important to take a closer look at the data. The telescope gives stunning views of nearby stars, but only shows fuzzy dots for galaxies far away. The Webb telescope can pick up light in 2 ways. It can use a spectrograph, which spreads light out like a prism, or it can use filters, which block certain colors. The redshift information helps us figure out exactly what time in the past of the universe we are looking at. The difference in star ages, or the fact that many galaxies have too many stars, could be because of problems with calibration, looking at galaxy clusters that don't reflect the whole galaxy, or problems with the current galaxy spectrum models that were made for galaxies that are closer together. These results make cosmologists rethink how the universe evolved, which is an exciting thought. If these galaxies really are very big, they go against what scientists thought before. We still don't fully understand the universe, as shown by the finding of a planet 13 times the size of Earth that orbits an ultracool dwarf star but is thought to be too heavy for its sun. This finding shows how much we still don't know about the universe and goes against what we thought we knew. In space, where galaxies don't behave the way we think they should and planets don't fit into well-known models, the James Webb Space Telescope keeps finding new surprises that push scientists to go back and improve their knowledge of the universe. It wasn't thought that the planet-forming rings around the low-mass star LHS 3154 would have enough solid mass to create the planet that has been found. However, the planet does exist, which has caused scientists to rethink their ideas about how stars and planets form. A good way to think about the star is like a campfire. To keep your body temperature stable, you need to get closer to the fire as it cools down. Similarly, planets need to be close to stars with lower temperatures in order to support liquid water. We can see a tiny change in the color of an ultracool star when a planet moves very close to it. This is because the planet pulls on the star's light or spectrum. Lastly, the James Webb Space Telescope has taken an amazing new picture of Uranus, the ice giant, that shows almost all of its dust rings. This picture shows the fainter rings that were hard to photograph and could only be seen before by the Voyager 2 ship and the WM Observatory in Hawaii. It shows how sensitive the telescope is. Uranus is 1.2 billion miles away from the Sun and has 13 known rings. The stunning new picture from the Webb Space Telescope shows 11 of them. Saturn's rings are flat, but Uranus's rings look like they are tilted to the side, making them look vertical. The Voyager 2 probe found the two outer rings in 1986. They were harder to see because they were made up of dust. The James Webb Space Telescope can also see infrared light, which gives us a new way to look at Neptune and Uranus. Hubble and other visible light telescopes can't see infrared wavelengths. JWST, on the other hand, lets scientists look at these planets through a new lens, showing depths and features that had not been seen before. With its infrared imaging powers, the telescope could help us figure out what makes Uranus's atmosphere so unique. In addition to finding new planets, the James Webb Space Telescope has taken amazing pictures of a star that is dying. When it was put into use in late 2021, the telescope caught the Wolf-Rayet 124 star as it faded and sent gas and dust into space. This event in space, which is about 15,000 light-years from Earth, shows a shiny purple piece of the star's outer layer, which used to be a mix of dust and gas that made the star flash. The picture is better than the one taken by the Hubble Space Telescope in 2015. It shows how technology has improved so that we can now see more details of the damage Wolf-Rayet 124 did. Scientists think that the exploding star in Sagittarius is 30 times bigger than our Sun and has thrown out enough gas and dust to cover an area the size of 10 suns. NASA says that this beautiful new picture is centered on a star. For 15,000 years, the star's light has been traveling through space, and it took another 15,000 light-years for it to reach the telescope sensors. The dust that looks like it's around the center star is actually dust. When a star dies, it sends its outer layers and other material into space, where it forms planets from the dust that spreads out. According to experts, a star that is losing mass is about to explode, which is called going supernova. People will not be able to see Wolf-Rayet 124 collapsing, but they will be able to see 5 worlds. The James Webb Space Telescope caught a strange spectral object hiding in space. It turns out to be a galaxy called Aztec C71. A ground-based camera found it almost 10 years ago, but the Hubble space camera couldn't find it. The lost star that was shrinking has now come back to life with the help of the James Webb Space Telescope. An artist's drawing of the galaxy, which looks like a scream into the abyss, questions scientists' ideas about how the universe began. It suggests that massive star nurseries were 3 to 10 times more common than was thought before. Even though it doesn't look like much, Aztec C71 is the place where hundreds of stars are born every year. The pictures from the James Webb Space Telescope are very sensitive, so even subtle things can be seen. Before the telescope, it was hard to take pictures of dusty galaxies because they absorb and send back sunlight at longer wavelengths. The Hubble Space Telescope can only see clear, dust-free galaxies in the optical range. The James Webb Space Telescope, on the other hand, can see groups of galaxies that haven't been seen before because it is sensitive to infrared light. With the help of the James Webb Space Telescope, the Cosmos Webb project wants to map up to 1 million galaxies and learn more about the early universe. NASA has also used the camera to find things closer to home, like taking very clear pictures of Mars. Even though Mars is hard to study because of its infrared conditions, the telescope's advanced sensors allow scientists to look at things like dust storms, weather trends, and changes in the seasons on the red planet. These amazing discoveries show how much promise there is. What the James Webb Space Telescope can see. The James Webb Space Telescope, JWST, has changed the way astronomers study the world and been a revolutionary tool for them. Its cutting-edge technology not only records amazing images, but also important data that helps scientists do their work. One of the most important things about the telescope is that it can look at the sky in infrared light, which lets it see through the dust and gas clouds that block many celestial events. Astronomers can study the birth and growth of galaxies, stars, and planetary systems with a level of detail that has never been seen before thanks to this feature. One of JWST's many impressive accomplishments is that it has shed light on how stars are formed in different clouds. It has been found that dust and gas interact in very complex ways that cause new stars to form. These star nurseries, which are full of molecular hydrogen, are where new celestial bodies are built. By looking at the chemical makeup of these areas with the telescope, scientists have learned more about the conditions that make stars form and how elements are made in these incredibly distant places in the universe. The Carina Nebula, a huge area where stars are being formed, has been studied a lot. The JWST found out more about how massive stars shed their outer layers and add to the environment of the universe. Of course, these processes not only add heavy elements to the space between stars, but they also affect how new stars and planets are made. When big stars go supernova, they send these things flying through space, making room for new solar systems. JWST has also made big steps toward understanding the atmospheres of other planets. Scientists can look at the light going through an exoplanet's atmosphere as it moves in front of its host star using transit spectroscopy, which is possible with this camera. Using this method, different parts of the atmosphere have been found, such as carbon dioxide, water vapor, and even complex chemical molecules. Findings like these are very important for figuring out if these faraway worlds could support life, since the presence of certain chemicals can show if life is possible. JWST has also looked at the atmospheres of exoplanets with its mid-infrared device MIRI, which gives a lot of information about the heat emissions these faraway bodies give off. Researchers can look at temperature profiles and weather trends with this feature, which gives them a glimpse into how these planets are changing over time. For example, finding different temperatures on the surface of a world can mean that there are clouds, winds, or even possible weather systems there. A big part of studying how galaxies formed in the early universe has also been done with the telescope. Astronomers can study galaxies as they were just a few 100 million years after the Big Bang with JWST because it lets them look back in time. This ability has called into question current models of how galaxies form, suggesting that they may have come together faster than was thought before. Observations of these early galaxies show that they have a wide range of shapes and compositions, which suggests that they have evolved in a complicated way through interactions and mergers. JWST's study of galaxy mergers also gives us clues about how these huge structures change over time in the universe. When galaxies crash into each other, they cause bursts of star formation that create new groups of stars. Astronomers can map the effects of these mergers using the telescope's high-resolution imaging. This helps them understand how galaxies are formed and how they interact with each other. JWST has given us useful information about our solar system in addition to its views of space. Asteroids, comets, and the outer planets are some of the things that the telescope has looked at. For instance, it has looked at Jupiter's icy moons, like Europa, which is thought to have an ocean below the surface. These findings are very important for figuring out if these moons could support life, and if they are ready for further exploration. The telescope's infrared powers have also helped us learn more about the Kuiper Belt, which is an area beyond Neptune where icy bodies live. JWST has taken pictures of faraway things, which help us understand their makeup and structure. Scientists use the study of these faraway worlds to piece together the past of our solar system and the processes that created planets. One more interesting thing about JWST's job is that it helps look for life beyond Earth. The telescope's job is to find biosignatures in the atmospheres of other worlds that could mean that there is or was life there. Astronomers are trying to figure out if these faraway worlds could support life by looking at the chemical signs of living processes. The idea that we might find life in other parts of the universe has huge effects on humans and how we see our place in the universe. JWST is also helping to learn more about dark matter and dark energy, which together make up a big part of the universe's mass and energy. Astronomers can figure out that dark matter exists even though it can't be seen directly by looking at galaxy groups and how their gravitational pulls on other objects. Dark energy's effect on the expansion of the universe is also studied by JWST's deep field observations, which helps us learn more about these strange pieces. JWST claims to find out more about the universe as it continues its mission. Together, the advanced technology of the telescope and the work of scientists from around the world should lead to groundbreaking findings. We learn something new about the universe and our place in it every time we observe something. This makes us curious and amazed about the universe's great secrets. To sum up, the James Webb Space Telescope is a strong tool that has changed the way we think about the world. Its discoveries about how stars form, how galaxies change over time, the atmospheres of other planets, and the complicated processes of our solar system have led to new areas of research. Scientists will continue to look at the telescope's data, which will no doubt change how we think about cosmic events and how we try to find answers to basic questions about life and survival beyond Earth.